Okay, let us see this next example. It says, find the center of mass of the uniform lamina below from AB. Now, of course, we saw this one, that this mass is going to be equal to the area, and the mass per unit area, then weight is going to be equal to the area times the weight per unit area. But because they're interested in mass, so I'm going to use this formula now for mass. If it was center of gravity, then we would have used the weight. So here now, the idea is, now is that this is having a line of symmetry. So it means that our center of mass is going to be lying on that center. On that line of symmetry. So if I call this one A1 and I call this one A2, the first thing we need is the area. So the first area A1 is going to be 3 times 10, which would be 30 meters squared. And so our weight 1 is going to be, this now is going to be mass, because we say they want the center of mass, then you can only use the mass. So to get the mass 1 for this one, we are going to get now the area, which is 30, now times the mass per unit area, which we say is m. So our mass 1 is going to be 30 m. Then when we come to our next area 2, we are going to say this is area 2, the length times the width is 2, then the length is 10. It's going to give us 20 meters squared. So our area 2 is going to be, our mass 2. The mass now for this body, M2, is going to be 20 times M. Because we said we get the area and the mass per unit area, but we say let the mass per unit area be M. So meaning our mass of the second is going to be 20 M. Why do we do this? Because to use the center of gravity, we need to be having a force, and that force comes from the weight which we get from the mass. So that's it. Because they want the center of mass, that's why I'm using M. Now from here, I can get the total mass. Now, because this one is having its mass and this one is having its mass, means that now the mass of the wall is going to be when I add this plus this. So the total mass is going to be 30 and plus 20 M. So the whole lamina now is having 50 M as its mass. So they are asking me from AB, so meaning all I want is the x coordinate of this, because it's on the line of symmetry, it's going to lie on the line of symmetry, but from what distance? So what I'm going to use, I'm going to use the formula. So if I want to get x bar, say you get sum of, now these ones I'm dealing with masses, mi, then times the x over the sum of mi. If you want the center of mass, if you want the center of gravity, of course now this one changes to W and this one changes to W. Now I'm getting one quality because they're asking me from, okay? So that means that they want the distance, they just want the distance x from AB, because AB is vertical, means that now from, we need the perpendicular distance from AB, which is going to be horizontal. So that's why I'm getting just x. So now from there, you can able to see, if I redraw the diagram here, as you can able to see there, this is going to be symmetric about that line. It has a line of symmetry. This is our A, B, C, D, E, F, G, then H. So it means that I have first of all a mass there for the first, which is going to meaning its center of gravity. is going to be there. Then even this center of gravity is going to be there. But here I'm interested only in the x coordinate only. So our center of gravity G is going to act there, which is x bar there. So the distance of from there, let me just say. My D is going to act from there up there when they are in x bar. That's what I want. Then I know this. Now I want, this is my AB, remember? This is 10 meters, this is 3 meters, this is 2 meters, 1 meter. All of this is 10 meters. Now, from here, we want the x coordinate only. So from here up to here, because this one is acting in the middle, so this one from here up to here will be adding 5m up on that part. Then, what about this one? From here up to here. So from here up to where this coordinate is. Sorry? Up to here, where this center is acting. What are we adding? We adding now the 10, and see this one is 2. So this one is in the middle, our gift is in the middle. So it means from here up here it's going to be 1. When we add this 10, it's going to be now 11 meters. So we have everything. So our this one is going to be exerting the weight, which is going to be our M2 20 mg. This one is also going to exert weight. Of course, this one is going to be now the total, which is 50 mg. And this one, of course, is also going to exert a weight there, which is 30 mg. So if we use our formula, so our x bar is going to be now the first mass into times its x coordinate, then plus the second mass times x second coordinate x2 over m1 plus m2. This one is the formula we use if they want only one coordinate. Now from, that's why I'm having only x. If they want the center of mass, then they would have given me the second axis, the horizontal axis. If they give you vertical, you just get only the x coordinate. So my x bar here is going to be, my m1 is 30m. It's a coordinate from FB. From FB, this one is going to be 5 from here up to here. Then plus the mass 2 is 20, and I'm using mass, not weight. That's why I'm not putting this D. This guy was showing for weight because we get the mass and must be. But I'm interested in mass now. Then times x2 from here up to a distance of this mass from AB. We get a 10 plus this one when we divide that because this is in the middle. So plus times 11 all over, adding the two masses, 30m and plus 20m. So my x bar is going to be, this is going to be 150 plus 370 m. Dividing it with 50 m. So my x bar is going to be 7.4 meters. Then we set, therefore, the center of mass is 7.4 meters from A, B, and that becomes our answer. Very happy. With a happy smile. So that happens if they give you one axis. You just get the x coordinate from as simple as that. Because this, whenever I see that, your lamina it has a line of symmetry. All you need to get, like you see, it has a line of symmetry from there. Or if it has a line of symmetry, and then you can ably, this is just uniform without these ones, you can ably also get your center of gravity coordinates with ease. So even here, you see if this line divides through it. So here we have got the y, even here the y, but this one just wanted from FB. That's why I just wanted this distance from FB. I never wanted, because I don't have any answers they are giving me to refer to. That's it. I wish you well.